Now for this demonstration, I'm going to show how the H-flow responds to a closed-ended situation as opposed to an open-ended tube where a flame would just be put to the open end of the tube. So over here I have a little container of water, and the tube from the H-flow output that terminates with an air stone. Now I use the air stone for a number of reasons. One of them being that it helps increase the concentration of gas in the tube, and it also helps prevent water from getting sucked back up into the tube because of the implosion characteristics of detonation of Brown's gas. And the air stone will also pressurize the gas in the system. So for example, if this is hooked up to your car, there will most likely be pressurized situations. So we needed to make sure that the H-flow was good in that situation. This also helps muffle the sound of an open-ended test. Another great feature of this little contraption that I've rigged up. Now what I have here are two electrodes that are sticking inside the hose. Okay, and there's a gap about this big in between the electrodes, and attached to the electrodes is a barbecue grill igniter. And what that does is put a high voltage spark across the electrodes, and that ignites the gas. And this basically represents any system where the Brown's gas would be fed into another device rather than an open-ended test. Okay, so let's fire it up. You can see that we're getting some bubbles over there. Okay. So this is running at like 2 liters a minute. Okay, so I'm going to push the button and you'll see the flashback result and get stopped. Alright, let's turn the lights off. Now did you see that? That was a sustained flame momentarily existing inside of there. But because of the check valve, it can only exist there for a fraction of a second. But you notice the flashback never gets past the flashback arrestor. Now we could sit here all day and do this. Alright, now let's increase the gas flow. If you remember from before, I have a ball valve over here. So I'm going to count to 20 and then we'll release the valve. Okay, so we're going to crack the valve. So I mean, if this is hooked up to your car and it backfires, you're in good shape. See, even multiple times. You notice it's not even getting past the check valve. That's why I say have one of these. You know, it also helps take some of the burden off the flashback arrestor, and it has replaceable diaphragms. Alright, now I'm not going to detonate it while it's out of the water, but there's the air stone. Now I have another flashback arrestor on the end there as a backup because this is a test rig, but so far in all the tests in this video there hasn't been any problems. See? Now listen to how the sound is muffled just from the end of the tube being in the water. Now I'm going to take the air stone off of there so you just have an open-ended tube there too. And you can see how that works. Alright, so I'm going to pop this off. Alright, so I'm just going to put the open-ended tube into the water. Turn it back on. This is 1/4 inch tube, by the way. Alright, and then I have it leading to 3/16 tube, and that goes into the water. I use the smaller tube because it helps keep a steadier output. Otherwise the large tubing would yield a pulsing gas inside here, and I didn't want that. We wanted a nice steady flow of gas. That's another reason I use the air stone too. So let's test that out. Watch. This rig is the greatest thing, I'm telling you. How did you like that? How'd you like that backflow of water there, huh? You see, it really is an implosion. Watch. Look at that water. It just sucks the entire tube full of water there. But the check valve stops the water too. That's what I'm saying. These check valves are the greatest. I know this is a commercial for the H-Flow, but our check valve is amazing. Now look at that, how the water just exploded out of there. Right? But the sound is so muffled because it's closed end. Now the water never gets past the check valve either. And the water would also represent a backflow of gas too. I mean, if it can pull the water through, it's a lot tougher for it to pull that water through than it is to pull some air through there. So the pressures involved are definitely greater than if it was just an empty tube. Now I'm going to increase the gas flow again. I'm going to count to 20. 5, 6, 7. I want you to see the gas flow that comes out of here when we let the pressure build up a little. Watch this. Alright, just so you know, I'm not crazy when I say that we can increase the gas flow to something like 3 liters a minute. Alright, it'll only exist momentarily, but the flashback only exists momentarily. So, I mean, there's really no consequence. I'm going to crack the valve and you'll see how it reacts. I'm going to turn the light off. Okay? Cracking the valve. See that? Amazing.